study sessions, okay? I tell you that because I'm going to keep y'all's the same, okay? I'm going to keep y'all's the same. But I need some help in terms of when we get started, we're going to hop right into the questions, okay? Because again, it will be kind of a long day. And so I want to make sure I do that. Just a heads up, that'll be Tuesday night. Just remember that accordingly. Also, the homework 3.2 is due tomorrow, preferably in class. I would prefer that in class because y'all's test is on Wednesday. I don't want the homework to be over top of your head Tuesday night while you're preparing for a test. So 3.2, I want that to be turned in by 3 o'clock tomorrow. Okay, so as you look at that, whatever that looks like for you, turn that in and we'll be good. Okay. Other than that, make sure you keep up on the reading. Today's lesson, R squared, from what I remember last year, was in the top 5 of most difficult things that I taught last year. Now, I think I've got a strategy to attack it. I think I like it better on how we're attacking it. But I say that because it is a little bit tough. Okay. It's the idea that we're going to look at here is this idea of R squared. What does it mean? We remember that correlation is related to R. If R was 0.8, we would know that R squared would be a value of 0.64, right? Because that would be what R squared would be there. It actually is a percent. We're going to talk about that percent and what that looks like, but today's lesson will be important in making sure that we really understand this kind of second to last concept as we're going through the test that's there, okay? One other thing before I let you go, because we're going to start with y'all kind of finding some of these values. The only other thing I would say is that the test day will end up being 35 minutes of review on Wednesday, and then the rest of the class will be the test. So no new stuff on Wednesday. It will literally be review and then into the test. And so I think the review will be really helpful for those people, for all of us, as we look towards the test. So just a heads up there. Okay? Questions? All right, do this. I'm going to read the context of this problem, and then I'm going to have you all kind of start the process of solving and going through that together. And then afterwards, we will dissect and formalize what we just did. Okay? All right, here we go. 5 students requested the counselors to update their transcripts. Okay, you have 5 names. You'll see them there. Their IQ scores were listed right here, but they have been all mixed up, and the counselors, they don't know what the IQ scores are for each of the individuals. Now, here's the idea. The guidance counselors are forced to predict the IQ for each of these 5 students, okay? And each counselor, there's 2 of them, they take a different approach with this, okay? So you'll see it here. Counselor 1 attacks it. He's kind of nervous about being wrong with these 5 people. So he decides that he wants to play it safe by minimizing his error. So what he does is he decides to find the average IQ of the 4, okay, or the 5 kids, okay? Counselor 2, he's a little bit more, or she's a little bit more of a veteran, and he or she decides that there's an equation in the AP stats room that corresponds to IQ score, okay? So she realized that the GPA can help her to make a better prediction, so she decides to take the GPAs of the 5 students, plugging them into the formula, to come up with the predicted IQ. Does anyone know what we call the predicted IQ again? Or the predicted value? Y hat, good win. Same thing, Y hat would be predicted, right? The actual value would be just Y. And then we'll go from there. After you're done, I want you to go to the third one that says that this is more of the truth teller. This is the one that pulled all 5 out of class and told the truth. So this is obviously going to be the closer one, right? The question is what happened to counselors 1 and counselors 2 responses? So here's what I want you to do real quick. I want you to come up with what's the predicted IQ for counselor 1 and what's the predicted IQ for counselor 2. Okay, I'm going to give you like 3 to 4 minutes. Do that quickly. Ready? Let's go. Right, let's do this thing. Put a little timer on. By the way, the Monopoly activity, when you get that done, even if I didn't stamp it off, you could turn it on the left or online. Okay, either one of those 2. All right, here we go.
Yeah, wait, that's the first guy starting with 1 average.
Okay.
All of their IQs are at that average. calling them Sharon average? That's stupid.
Yeah, they're all going to be the same, right?
That guy's horrible.
Why?
He's not even trying.
I hear you.
He's like,
It's actually pretty true.
yeah, that's horrible. You don't want to agree.
No, you're good. Did you get 86.1 down here, Emily?
Yes.
Perfect. As you start filling things in, I might have a couple of you just kind of put some stuff up on the board, make sure we've got the same values.
I'm confused.
Yeah, go ahead. Go ahead, Ryan. With counselor 1 or 2?
Counselor 2.
Okay.
I'm pretty sure I'm not getting those numbers.
Did you put 1.8 in for the GPA?
Yeah.
So when I put that in, right?
Is that 1.8 times 16?
Perfect.
Is that in parentheses?
Yes, and then once I did it, then I add 57.3, right? So these, again, these are predicted values after plugging it into my equation, okay? Fun. Again, I'll have a couple of you come up here in just a second.
That's a pretty low IQ.
You also do counselor 3 or no?
Counselor 3, you're good on. Because that right there was just kind of
I
given,
didn't
right?
see that. My bad.
They already found them, they're already good.
Okay, can I throw this?
Cool. You may, yes ma'am. All right, what'd you get up here?
103.
103, right? Okay, good. I just want to make sure we're clear. All right, what'd you get down here, down yonder? 86.1. What's the next one?
95.7.
Nice. Next one?
103.7.
Good. Next one? Good. And then the last one? Good. Some of this will be collaborative today. I will tell you, though, most of this is going to be a little bit different than normal. It'll be more me going through some stuff. So just a heads up, we'll kind of do a little bit of both, but a little bit more of kind of instruction as we go through. So we got sheet number 3. We're good there. Did everyone get those values? Everyone on the same page? All right, here we go. This is get us some tickets here. Now we're going to see who made the better prediction. Okay? First off, Grace, you said the counselor 1 didn't even try. Would you predict counselor 2 was better?
Yeah.
Why would you say that? I'm just curious.
Overall, the numbers, the difference between the numbers that was predicted and the actual is not far apart compared to counselor 1.
That's 4 tickets. That's pretty good.
Yes.
That was just, I just felt it. I felt that, okay? She said exactly what we're going to do here. So we're going to ask the question, how far was our residual, right? Because if our error is less, then that means that counselor would be the best. Does that make sense there? Whoever had the least error. So here we go. The predicted IQR, or IQ, my fault, would be the ones that you listed earlier, right? So this would be the ones that we have for counselor 1. So this would be 103 across. Okay? So question, how would I do my actual minus my predicted? Well, they already gave you what your actual was, right? Based upon counselor 3. So we're going to take actual minus my predicted to find what my errors are here. Okay? So what would be the error of the first one? Negative 18. Good. Good, Fiona. What would be the second one? Negative 8. The third one? 7. Then what? 2 and 17. Good. Good, good. Okay? I think it's because it's AP, right? So it's actual minus my predicted. So when the actual is less than,
Yeah.
so that's a great question, Claudia. Claudia, would this negative 18 residual be below or above the LSRL? Below, right? Are we all kind of relating this? Okay, good. All right, so now we're going to square the error. Here's the thing. I'll give you these. Y'all know how to square numbers, right? All of these will turn into a what? Positive. So 324, 64, 49, 4, and then the 17 squared. Does anyone know 17 squared? Did you just know those?
No.
Yeah.
Oh, okay.
Those
Eric,
are-
we
Yes,
did?
I totally
What's
did.
on
I'm
the
just a
floor?
mathematician.
I do.
It's like,
I know.
okay.
It's so great.
Yeah,
All right. Good.
No, confidence is key.
That's true. This is true. Okay, so here's the deal. The sum of these squared values. So if I were to add all of this up, let me give a different color so you got this. And I would even circle these. The sum of the squared values would equal 730. And I think there should be a box right below it. 730. Okay? All right, so we're going to come over here. We're going to do the same thing on the second one. All right, so we've got our actual and our predicteds are a little different. So this is 86.1. I'm just going to kind of fill this in as you're writing here. 95.7, 103.7, 111.7, 118.1. So our errors, our actual minus predicted, would be what for the first one? Negative 1.1. Nice. What would be the second one? Is it negative 0.7?
Yeah.
Yeah, negative 0.7. Good. And the third one? 6.3. Y'all are awesome. That's good. The next one is negative 6.7. And my last one is at 1.9. Good. Okay. When I square it, again, I'll do the same thing. This is 1.21, 0.49. Again, I'm giving this to you because right now, I know you know how to plug it in. 39.69 and 44.89 and 3.61. Okay? Again, when I add all these together, you get the sum of the squared values. The sum of the squared values for this one was 89.89. Okay? All right. So, who did better and why? Any ideas there?
So is it because the sum of the squared errors is less than the counselor 1 and counselor 2 did better?
Perfect. You said that, Vonna, that was awesome. Sum of the squared values, my fault, is smaller for counselor 2. Therefore what? Yeah, therefore, we would say that it was better, right? They had a better guess. Therefore, counselor 2 had a better guess. I think I could write that better, but that'd be good. Better guess, that's there. Okay. And the error on that, so that her sum of squared errors, that's kind of the big thing. Sum of the squared error values, probably sum of the squared errors, that's probably a better way of saying it. So make sure we're talking about the sum of the squared errors. Awesome. Stuff right there. Sum of the squared errors is smaller for counselor 2. Therefore, counselor 2 had a better guess than 1. Okay? Is there any question on that? All right, we're going to talk about this in just a second as we kind of progress here. And again, I think I told you this, that this is something to kind of, it's to struggle a little bit, okay? So we have to kind of wrestle with this. So ask questions as we go. Counselor 1, we knew the sum of the squares was what again? 730. 2 is 89.9, right? Okay. 89, that's right. Perfect. Okay. So the question is we're going to calculate the percent improvement of the sum of the squareds from guidance 1 to guidance 2. Okay, so if we looked at the percent improvement, then wouldn't we take 730 and subtract 89.89? Okay? Does anyone know what I would then do after that? Divide by what again? No.
Or
Thank you
square
very much.
squared by base.
If it's the percent improvement, right? I'm finding the difference of these and then dividing by my 730, which was my initial, wouldn't I? Do this real quick. Put in 730 minus 89.89 divided by my total that was from counselor 1.
87.7%.
87, and yeah, then we could multiply it by 100% or whatever. But 87.7, that's there. So we're talking 87.7% 0.7 or 0.8, and this should be percent if I did that. Or you could say 0.877 if I was talking percent, or if we were talking about like a proportion, okay? All right, so real quick, as we look at this, the question is now we also could find each counselor's typical error, okay? All right, so how could we use algebra to turn the sum of the squares into the average error? Okay, this is interesting. What can I do with counselor 2? Let's look at counselor 2 here. How could I do it the average error?
If you found the average of the IQs and then the average that they.
What was the sum of the squared errors again? 89.89, right? Question, what can I do in order to get the average error?
Divided by 5.
Bingo. Yes, that's exactly right. Good job, guys.
Yeah.
Good. Was that you, Wayne? That said that? I know it was also here, too. I got one for him as well. Good. So 89.89 divided by 5 gets me 17.978. Okay. That's the average error. Would you agree? All right, so I'm really sticking to my script today. If you notice, sometimes I fly with it. I'm really making sure I'm specific, okay? So I want to make sure we're all clear. We get on this one 17.978, but what do I have to do with that value? Now, think about this. Go ahead, Grace.
You gotta undo the square.
Yes.
Square. Yeah.
The square root, right? I love it.
Yeah.
I love it.
Gosh.
I love it. It's just for the help, too. That's good. So we square root this because why? Why?
Because the sum of the squared error is squared, so then it doesn't actually find the average.
Good. So what did we just do? Well, first off, it's 4.24, right?
Yeah.
Okay, question. All right, big idea here. I'm making sure. Who's here? Ivana, what did we just do? Yes. Yes, we did. But what type of standard deviation did we find? 6 tickets, if you know. If you could raise your hand and tell me. Charles, average of what? You're right. Okay, talk about that with the scatter plot. You're right, you're right. You're all over it. It's the average residual of what? What does standard deviation mean? Just, what does that mean? Yeah, average distance each value is from the mean. We don't have a whole mean, right? A scatter plot doesn't have like a mean when we think about it. So it's the average distance each point is from.
The sum of squares or
It's the average distance each scatter point is from my LSRL. Think about it, right? If it's the average residual, that's technically right. What is the residual? It's the distance from the point to my LSRL. Do you get what I'm saying here? Okay, say again. Yeah, technically it's like the average residual. It's the average distance each of my points is from my LSRL. Okay? All right? So that's what we're looking at. That's why we're looking at it there. All right? Now, here's what I want to do right below. Real quick, how would I plug this into my calculator? Well, let's do this real quick. Let's plug it in. And when we plug this in, I want to show you something real quick. So let's go here. What do I put in for L1? Let me see, back up. Yeah, you want to make sure when you edit, you're going to clear these off, clear and go down. So your X is your L1 and your Y is L2. Torrance, you said something, right? What'd you say? Good, that's exactly right. So I'm going to plug these in. I got 1.8, 2.4. 1.8, 2.4, 2.9, 3.4, and 3.8. Good. Okay, so on my L2, I've got my response here, which would be 8595. $105 and 120.
Yeah, that's not working.
Okay, we're good?
Wait, one of them is 10.
Yeah, one of those things.
Oh, might be. My fault.
Okay.
Man, It must be my meme today. That's what it is. I know. No, it's bad. Wow.
It
Y'all-
wasn't me.
Are you gonna let her just treat you like
Oh,
that?
she's got a test this week.
Oh.
Oh, no, that's really bad. I'm sorry. I can't even joke about
Is
that.
this on podcast?
Yeah, it is. That actually is podcasting. I'm sorry. If you're listening to this and you're administrators, I'm sorry. What's that?
Why are you caressing the
You're
computer?
like, podcast, you know.
I was back in the podcast and like, what were we talking about?
Yeah, I'm gonna delete this part. So
No,
just
keep
remind
it
me.
in.
No,
Keep it in.
It's a memory.
We'll do it. We'll do it. Keep it in. All right.
Try to black it
All right. So this time you have to go to 2-bar stats. The reason why is because you have an L1, L2. Does that make sense? Before we did L1, this is now going into more of an L1 and L2 within your list. Okay. So when you calculate, you'll see that you got all of your stuff that's here. Okay. All right.
Wait, what is?
Is that what y'all got?
Yeah, but I don't understand what everything is.
Oh, hold up. Coach, you're bad. No. I don't know why I just did that. I'm sorry. What are we doing? We've already done this before. We're not doing 2-var stats. What am I thinking? Linear regression, aren't we?
Yeah.
Right?
Yeah.
We've already done this. This is my fault, okay? When you go to linear regression, you go L1, L2, press enter. That's what we're focused on, and that's what we're doing. I'm sorry.
Linear
Okay.
regression.
Wait, what?
So you've got R squared, you got R, you got your correlation, you got your R squared value. Okay, we'll talk over that.
I didn't get that.
Well, you put it in wrong.
You didn't?
Oh.
You put it in differently?
I don't have the R.
Yeah, I don't have the.
If you don't have the R, you'll have to see me because you have to do one thing on there, okay?
Yeah, I know.
So I'll help you with that because there's something you got to do.
Wait, I have a question.
Yes, ma'am?
My A and B are switched.
Your A and B are switched, that's okay. What you did was, when we looked at what Fiona brought to us, sometimes in algebra, you do AX plus B, Y equals AX plus B. There's a second one down there that's Y equals A plus BX. As long as you plug them in right, you get the same thing.
Okay.
You'll have the same thing. Great question. Good question. Okay, here we go. Now, R is this, 0.936. R squared is 0.877. My standard deviation was from up here, 4.24. Okay? All right? Now, one thing that I need you to know is that this is a side note. Don't need to necessarily memorize this, but just know that 5.473 was another standard deviation. When you divided by the square, or divided by n, right here, you see that? Sometimes there's a formula where you take n and you subtract 2. So it's n minus 2 divide by, in this case, then 3. So this would be 89.89 divided by n minus 2, or 5 minus 2, which is 3. This is something we're going to look at later, and it has everything to do, do y'all remember that there's 2 different types of standard deviations?
Yeah.
There's one with an S and one with the one we've been using is this, okay? Just know, you don't have to memorize that now. It has to do with that. We'll talk about that later, okay? You're not old enough yet. We'll talk about it later, okay? All right, here we go.
How
Now,
much older do we have?
a lot older.
Oh.
Yeah. About a chapter too young, okay?
Wait, why is there a main jacket?
This is my jacket that some of my students got me last year.
Oh, that's
No, I don't mean it.
It's really sad. It's really sad.
That's kind of funny though.
They even got me a hanger.
It's
right
North
there.
Face though.
Wait, it's North Face?
Yeah, it's North Face. It's nice.
Oh, okay.
I use it as an eraser. All right, I've got to focus. All right, here we go. Now, this next part, okay, I'm going to try, I'll be honest, I'm going to try to attack it a little differently than last year. Last year, this was probably on my top 5 of the lessons that I wish I could have redone. And so I'm going to try to attack this and try to go after it in a different way, okay? If it doesn't stick, then maybe I try something different with you. But I know this helps me, I think, and I think it will help you on this, okay? All right, here we go. So you may want to take a picture of this. You may want to just listen, okay? And then kind of come back and maybe write this down later on, all right? So there are 2 types of pizza places, okay? You got Michigan Pizza in Ann Arbor and Bob's Pizza, all right? Yeah, just okay? Now, R squared, in context, okay, this is a big thing, stands for the power. Now, that should make sense to you, because when we think of correlation, R, we usually, like if we have a good correlation, that would be like 0.9, right? But if I took r and I squared it, what I would do is literally take 0.9, square it to get 8.81. Does that make sense? So 0.81. Literally, r squared relates with correlation. So the tighter it is, the higher the r squared value will be. Okay? Now, here's what I do want you to get down. R squared is also related to what we call the coefficient of determination. Okay? So if you see these two names, they're the same. Okay? Coefficient of determination. Well, r squared, if I were to boil it down, it means power. It's the power that's there. Okay? Now, let me give you two illustrations. With the Michigan pizza, when we go and get a pizza, you pay $10 for a cheese pizza. Okay? So that means with 0 toppings, we would expect that there would be a point here because at $10, that would be the y-intercept. That would make sense. Because $10 would stand for when you get a cheese pizza, that's how much you would pay up front. Am I make sense on that? Okay? Within this pizza company, you'll notice that for each topping, whatever topping you put on there, you get 50 cents or you are charged 50 cents per topping. So if you get 3 toppings here, you're going to be charged 50 cents or $1.50 for those 3 toppings, and so on and so forth. Okay? Notice that the variability or the change in our scatter points, there's not a lot of variability, is there? Okay? They're pretty tight together. All right, but over here at Bob's Pizza, it's a little different. Bob's Pizza, same thing. You get charged for $10 for a cheese pizza. But depending upon the topping, the different toppings are different prices. So when you get, let's say, 3 toppings right here, you'll notice that there are different prices at those 3 toppings depending upon the different toppings that you choose.
Oh.
Does that make sense? Okay? Any questions on that? So your price depends on what types of toppings that we have here. That's why there's different scatter points within 3, 4, 5, and so on and so forth. Okay? All right, so question. Or the topic we're going to go over is this. The LSRL model is modeled by 10 plus 50 cents times toppings. Why is this consistent with 50 as my slope, Ivana?
Because it's 50 cents per topping.
Perfect. And then why is it 0.64 for my second LSRL model? When? Yeah, it'd be the average for at least the data points that we have, right? Okay? So that's how we would get this right here. Now, when we look at r squared for this model is 100%. Okay, I'll talk about that in a second. This model, or the power, is 72%. Why is this higher than this? Grace?
Is the one that the 100% one more accurate?
I want to be careful on that. I hear what you're saying.
Yeah.
It's not more accurate. Maybe a different word. Although I hear what you're saying.
Okay.
Maybe a different word, Hannah.
All that your points on the LSRL are
Perfect. Yeah. What would be the R for this value? What would be the actual R value?
maybe 10.
Never.
1, like the actual correlation, right? Does that make sense? So therefore, it corresponds to 100%. This R squared is 72%. If I asked you what is the R of this, what was the correlation of this? What would I do? Square root it, right? And that's how you would get your correlation or your tightness. Now this is still pretty tight. 72% still has a high power. However, this has higher power than this. That makes sense. Okay, so watch this. Let me tell you what R squared is not. R squared is not the percent of points that goes through it. Okay? That's not what it is. It's not 100% of points go through, although it looks like that, right? That's not what we're talking about. You could have 1 point on this line, but that's not what it's referring to, not the percent. Okay? So that's what it's not. When we look at variability, that's what it's focused on. It's the variability of this data. So variability, remember, big picture, it's how things differ. We talked about that in like chapter 1, right? How wide things are, how things differ, okay? A lot of times we look at standard deviation that way or range in that way, right? But variability is how things differ. So when we look at 100%, really it's 100% of the differences in our money is explained by the differences in topping. Let me say that again. 100% of the difference in my Y, or my money in this context, is explained by the differences of my X. That is the definition of R squared, okay? We're gonna look at that a little bit more, go over the golden nugget again. But that right there is a big, big concept we'll continue to look at, okay? Did that make sense a little bit?
Yeah.
Yes.
Okay.
You did good.
Alright, that was it's a tough concept. It's a tough one.
But you can, so that you're gonna say, percent, probably maybe. Are you free? I mean, after 9:30 I am. After what? After 9:30 I am.
Alana,
It's basically the
when you
same
go to
thing.
the hearing, can you please check to see if you guys have those masks?
If we have what?
Those masks.
I'll look, but I don't